So today's a kind of a basic overview of the diagnostics of small commercial buildings. This is one of the most hardest topics to actually present on, and we have a capacity crowd today. So we're really excited about this kind of topic and how it could benefit you and your career or your training you may be doing, or also the type of work you have out there. I have several polls that I want to do to try and get an understanding about what kind of folks have joined today, and we'll go through those. The objectives today will be kind of a, there's really kind of a non-definition of small commercial buildings. I described it earlier to somebody else, is that these kind of small commercial buildings are kind of like teenagers. They're really hard to describe. They're can be troublesome, very challenging. They're no two are really alike, and they're really kind of hard to describe. And if you have a teenager, had a teenager, or remember being a teenager, all those things will kind of come into play when we kind of talk about the challenges of small commercial buildings. Residential, and most of us live in one of those, so it's easy to kind of understand those concepts. And between maybe a condo or a residential structure, that's really kind of like some of the basics and differences. And when we get into larger structures, more like warehouse versus high-rise. But the small commercial buildings are really a large demographic and variety of options. Today's presentation will mostly focus on existing structures. I'm not really going to go into the new or how to reduce energy code or do testing for new structures. It's more about the fact that there's an enormous amount of these types of buildings and structures out there that are in need of improvement. The goal is kind of an investigative approach. It's not a scriptive or thing you must follow. I'm not here to teach you how to do a standard, but teach you actually how to approach these types of, sorry, I was trying to read some questions. Trying to actually address some of the challenges that these come along with. It's kind of scratching your head, figuring out what's the best approach for evaluating these structures, especially when they're attached maybe to another on either side, like a strip mall. We did send out an email ahead of time that had a small library of great reference material, so I want to make sure that you have that. So one of the objectives today is to also determine what kind of training we need for some of these applications. The residential market has kind of been overrun and waiting for maybe more weatherization of money, but the reality is that there will be some challenges that actually come along without having to have some higher beam support. These types of structures are either backed up by maybe a utility or maybe code compliance, but I think this is the next move that a lot of people really want to be open to between small commercial or even the larger buildings. So we're trying to find out maybe what's happening near you. Please go to Retrotech and register. We do ask some questions about how we understand you as a trainer or as a rater, as a tester, as an auditor, or whatever your profession kind of defines. Or just send us an email at training@retrotech.com and let us know how we can make these types of webinars focus on the types of objectives you are after. Let's go with a quick poll here. I'm going to launch. So I'm looking for what is your industry. I can let you know that there is no BPI credits today. It wasn't something we're trying to negotiate or work on. There will be in the future for these types of webinars, but we'll kind of get a handle of what type of folks are out there. I glanced over the emails, and there was a variety of all right, I'll do 2 more seconds here, and I will close, and I will share the results with you. All right. I unfortunately can't have a hard time seeing what the screen has. So I'll read them all to you just to make sure we're on the same page. About half of you out there, which is over 200 already, are auditors or lead professionals. I got a few installation folks, a few builder modelers, a few HVAC folks, and some T&D, that's testing and balancing folks also. This, I feel like this is going to be the next weatherization boom, is these types of structures and the large structures that are there. Again, if you have any specific things you're hoping to get out of today, make sure you email us or at least register at retrotech.com. There will be a follow-up email that goes along with it today. Here's some of the resources you should have found in there, from the fantastic to some phenomenal articles that Colin Ginge has actually written, some of which were in Home Energy Magazine, or a great article on multifamily testing. It's a manual, but it's actually a lot of great individual applications about how to do some things we'll talk about today, but more in depth. And at the end of the presentation today, I have a new piece of equipment that Retrotech has now gained the rights to use here in America. And Acronym has a power flow hood called the Flow Finder 2, and it's a remarkable product. And based upon how all things are happening between lead or testing fans and ResNet and the HERS requirements and the ICC, I think this is a product that people are going to want to pay attention to. There are some other resources besides Retrotech.com. Several people I want to thank that provided me some input today and resources for you to go to. If some of these icons are not familiar, I recommend you check them out. The Air Barrier Association of America is just a phenomenal resource. It has a library of articles and videos and anything you can imagine on there. Some people will talk about standards but not really go through them, but the Army Corps of Engineers is the most talked about or referred to, and their their standard is free. NEB, the National Environmental Balancing Bureau, is one of the growing industries that I've seen out there. In some parts of the country, they've been there a long time. They now have a new BET standard, the Building Envelope Testing certification that goes along with that. So they're one of the first groups to really put together a standard that you can be certified to do the large building and air barrier testing. And if you haven't been to buildingscience.com, I recommend you go there because it's the source of everything. And I highly promote Southface and their Earthcraft program. It really is a great way to actually do compliance. They're really moving further in the industry and definitely compete really well with LEED. And it's a much smaller footprint or challenge to actually comply with Earthcraft. So I highly recommend you review that process. So it's a non-residential definition of how we would define small commercial. All right, 1 to 2 floors, typically 25,000 square feet or less. It's usually a lot less than that, but in general, these are kind of how people describe that. Has numerous occupancy types, from a simple standalone shell, kind of a structure, almost a hangar. Some are actually not even heated or conditioned. Some have incredibly complex or industrial installations that even go beyond something that's specific for that industry. And you may be connected on multiple sides, which actually creates a challenge when you're trying to actually do the envelope testing. And there is really no single group to kind of define these. That's why I kind of described them as teenagers, that they really are into a world of their own. I got some information here from Earthcraft that's very common knowledge, but in general I wanted to promote their program. Well, you see the energy use kind of by sector. You've seen these before, but commercial is really falls right along with residential. And if you pay attention to any part of our industry, it keeps talking about residential, residential, and residential. And I know there are fewer programs that actually are self-sustaining or money-back guarantees with commercial. The reality is they actually have the ability to invest in the structures they own or their businesses to do the kind of thing that some individuals really right now aren't able to do. So I highly recommend you reevaluate your business plan to see how these small commercial properties actually could fit in the way you actually been working with residential clients, because the reality is they actually have some money to invest in what they're doing. And in general, there are a lot of these structures out there. We know there's a lot of existing residential structures, so of 25,000 square feet or less is large majority of these types of structures. And many of them are aging. Some of them are newer strip malls, but in general, the building boom happened in the late 90s and early part of this turn of the century. So they're still going up, but there's a lot that are 10, 12, 15, 30 years old. We live right down the street to many of these all the time. We drive by them all the time and kind of forget what actually is designed in those structures. I use the phrase building phylum because commercial is a whole different species. Really, when we think about residential, I usually refer to as commercial as a whole other animal. So, they have their own individual design conditions. Some of this I know you're familiar with, but I'm trying to set the stage. But I want to make sure you understand, what is the HAC system or the HAC system, because ventilation is a challenge for these structures. So I'm not going to go into ASHRAE 62.1, but I do want you to focus on what's the significance about the type of structure that you might be evaluating. What are the proximity? What are the sources that may be causing the impacts or the issues? What are the things that are actually affecting their air barrier or their pressures or their moisture problems, or the things that are there that we usually forget that the neighbor actually may be the source of the problem. If you do want to get some really great information about ventilation, I highly promote the residentialenergydynamics.com or RED. He has some amazing products that you can either download, you can purchase, and he has one online. Most of them online are free, and you can learn a lot about ventilation issues, and some of the things we'll talk about really still kind of could apply from residential to commercial. But in general, if you're looking for a phenomenal source, we really promote this site. And Retrotec itself is phenomenal. He did a presentation the other day on the ventilation. I was pretty amazed. Pardon me. So the one question that I constantly try to remind people about, we've all learned technical skills, unless you're audits or lead, and the reality is you probably have a variety of skills that are technical, but we kind of forget how to communicate with our clients. So the question is, why are you there? Is your commercial property person have an energy bill or want to improve a green business model? Is it comfort issues? I try to remind people about the radiant transfer issues that are usually forgotten about, that it isn't an HVAC issue. It's actually the fact that they have too much glass or poor insulation, and somebody sitting near that type of structure or windows in the summer makes it hot, but in the winter will feel really cold. And it isn't air temperature, it's actually that their body heat is radiating all of its temperature out towards the cold surfaces. Are there any kind of suspect conditions or issues? Pardon me. And I rarely have ever been into a commercial place that didn't have those. If it has a drop ceiling, the first thing I'm looking for are stains. I got a couple slides that deal exactly on what's actually causing the stains, and it's usually not a roof leak. This is one thing I really put in here, and it's only part of one slide, but it really could be half of this presentation, is take the time to ask a lot of questions and more questions and listen, and get a good history from the many occupants that may be in the structure, not necessarily the owner, because their information is more valuable than most diagnostic tools you'll do. All right, I'm going to throw up another quick poll. I just want to find out what kind of standards, or are you testing anything now that deals with a small commercial? What type of things you see out there? If there's something that's not on the poll, please feel free to throw it in the question panel, or email us directly, like, oh, such and such we have in our area, and it's really working really well for us. All right, I'll wrap it up here a little bit. Everybody's kind of chimed in, and I'll cut it short there. I'll share the results with you. So a fair amount of you are doing lead. I studied lead for a while, and as if you do it or if you don't do it, it has some challenges, as they all do. That's good to see. There's several, about 12% that are doing utility out there. That's a great opportunity. IECC is going to change commercial buildings and large structures, and again, the small kind of fits somewhere in between, but they're going to have a larger impact. It's already happening in Maryland and Washington and other states that are now pushing the code and requiring these types of testing, and clearly the majority of you are not doing any kind of commercial or large building, And if you're like me, that's something that everybody's highly interested in and wants to increase their opportunities. I want just sort of one more real quick because it kind of goes together. What are your local codes wherever you're at? I have 200 and almost 300 people here, so we still try to get a handle on the fact that one state may say that they actually have a requirement, but that county or your municipality may have something that's a little different. So if there's something you don't see here, or if there's something that you want to help us be well informed about, please, again, send it in as a question or send us an email about what's kind of happening out there in the industry. And the other part of that is that you may have the greatest codes in the world, but is your building official or your code official actually have the time? Because I'm not here to knock anybody about not doing the job. The reality is that most of that staff has been cut short, and they're trying to do 5 people's jobs from 3 years ago with one guy. It is a challenge for what they do. So I understand that they can't do everything they want to do or want to be a part of that. So it is a challenge. All right, the results are about 16% of you have air barrier testing. That's actually phenomenal. I know California is requiring that, and they're using the HERS standard to do that. Some people are using an ANSI or U.S. Army Corps. 10% have their own jurisdiction or something they're developing now. Please let us know what that is. Maybe we can help you with some documentation. And about half actually don't have any right now. So that's kind of what I expected to see from those kind of polls. So the question is, why not? I took my energy management course almost 2 years ago, and they talked about light bulbs and HVAC equipment and economizers and chillers and more things that I can never imagine. And they went back to lighting again, and out of the entire 4-day class, nobody talked about testing the envelope. I was stunned that that was not part of how they imagined that you could actually reduce your energy load, or most people don't want to pay for comfort. They want to see what their payback is, and it's shocking how well you can actually pay back part of your commercial property or your large structure with actually reducing your infiltration. One of the logistics in doing these type of evaluations is actually, realizing that OSHA could be around because these are commercial structures, and your basic evaluation. This is not a show up, I pull out my door, my tester, or duct tester, blower door. Test it and go, kind of do a walkthrough. The reality is you're probably going to be there for several hours without even actually pulling out any equipment yet. And a diagnostic test could actually take 5 minutes to do the blower door, but it could take up to 5 hours to set it up depending on the structure. I mean, that's why this is such a broad topic. What type of HVAC system or other equipment do they have? What needs to be sealed off? What kind of challenges do I have that may be related to the occupant next door? And are you evaluating the conditions during peak performance or in the middle of the day when nobody's really around? Are you able to see the impact of what does 45 people in a small room do to why they're talking about high energy bills because they're running their air conditioner too long in the summer, or moisture issues? So a variety of stuff comes into play, but you need to actually understand their whole business model and what happens during the day, maybe during the evening, or whatever it is that actually impacts this structure. Again, this is not a testing standard. If you do want to get a hold of a standard that's free and not want to have to buy one, the U.S. Army Corps Engineers has one. You can do any kind of Google search, and I'm sure you'd find it. And I do want to remind people that commercial occupancies have what's called fresh air requirements, but the reality is it's really just make-up air for occupants. So whenever I use the word fresh air, other people do, they're like, well, it's really not that fresh. Where's it coming from? It may come from the roof and what's next door. And so I took out the word fresh air to remind you it's what it was, but the reality is it's really make-up air. And there's a variety of ways that can happen depending on, again, what kind of climate zone you're in or what type of structure it is. The most primary thing that we want to kind of focus on a little bit is where is the air barrier located. I mean, this is simple stuff you may be doing in a residence, zonal pressure mapping, and here you can actually do a fairly good zonal pressure map without any blower door happening. A lot of these structures have enough pressure between the indoor and outdoor that you really could go around with a gauge with what I call the active environment, which is either HVAC, if they have a lot of fans as a kitchen. You can actually find out a lot about the structure with just how it actually functions in its normal activity. And I would recommend you test kind of high and low really around the entire structure and kind of find out what's really happening. You're actually going to penetrate the wall with a little probe and have your reference tube going outside and kind of determine what kind of pressures we're having. Do we have a lot of leakage that's up high or low, or what are the issues that are dealing with adjacent structures that we actually have no idea what's happening or have access to. Determining whether it's not possible on a windy day to do some of these types of tests, so you really want to be careful about what's actually happening outside, because that will not just where you put your hose for your reference, but it'll actually impact the pressures on it. Or if you have a large temperature difference, the stack effect can be incredibly significant. You could have a 5, 10, easily 15 Pascal difference depending on what kind of temperature difference it was or what kind of structure it was. High rises can have an enormous amount of pressure difference between the ground floor and, say, a 30 floor at 30 floors at the top. 15, 20 Pascals is not that uncommon, depending on the condition, the sun, and the issues that are happening that day for the wind effects. I do remind people that the tubes are affected by temperature. Air is fluctuating, or the sun. They can heat up, or if they're incredibly cold, all that affects actually your gauge and what kind of readings you're going to have. So leaving a tube outside for 25, 35 minutes while you're trying to do some of this diagnostics and realize it's in the sun may be actually affecting your test results. And then the question is who's next door? How do I access these adjacent structures? And what kind of impact does that have on the structure I'm trying to evaluate? So I messed up my slide. I'm supposed to take out the blocks in the previous slide. So anyway, so one of the things we want to address is how do I actually test a center structure? Maybe it's the corner structures has one occupant next to it or some type of structure. A lot of these are kind of strip mall kind of concepts that you're in the middle or you're on the end. You could actually be somebody on the top and bottom. This starts to play into the same type of concepts for a multifamily structure. So how do I just isolate this one unit and determine really what's the leakage and where do I have the strongest leakage into what area? One of the greatest issues that I actually have experienced with these types of structures, especially if they have any kind of a overhang or the walkways, is the too much plenum that's actually non-ducted. So what I have here is in the green area would be the roof line, and this would be maybe a drop ceiling. You can see my cursor. Right, so above here I actually have the return, which has it's an unducted return. They just kind of use the open area above the ceiling as a return system, as a return path. And the challenge is that where is that actually connected to? And a lot of times it's open to any part of the exterior walls, the neighbor's walls. Sometimes it even go directly into the neighbor's unit. And most commonly it'll go to the out front with a walkway. So if I'm trying to figure out why do I have stains on the ceiling, a lot of times it's because I'm actually bringing in temperature and moisture from the front walkway into the plenum area, and then I end up with condensation issues with ducts I have or water pipes that are there. You can see in the picture I have in the upper right corner outside with the can light versus inside and the issues that it has. These are some kind of examples showing the common conditions that happen in these kind of strip malls with this overhang and how they're more frequently connected. A lot of times they actually may have a fire stop or they have the drywall coming up, but they really weren't an air barrier type of installation. So again, I have different temperature of air coming in, right? It could be hot, typically it's coming in, connecting with the ducts, the water pipes, condensing, dripping, and now next time you go into a facility, dentist, doctor, tax accountant, whatever, and they got the drop ceiling, take a look at these stains. Many of you may realize that they're probably not roof leaks. They're a condensation issue. And condensation issue usually means they have some kind of air leakage. And most homeowners are less motivated to want to, improve the performance of their structure. But when somebody has a business, it can be impacting their business if it has to be shut down or other issues. So I think many of them have a different agenda when they actually realize that their concerns that aren't just necessarily my energy bill, but actually how it could be impacting the structure, even if they're a renter. So it's not a typo. I actually refer to it as a droop ceiling because that's kind of what happens after they have the issues of too much moisture starts to sag. You can see where you take down a tile and you actually can see the exposed walls on the edge. Here's one that I have from Allison Bales where it actually has a fan above it. So it's not only trying to do like the attic fan concept, but totally affects the entire structure and probably pulls out all the conditioned air below the drop ceiling. I'll throw a poll out at you. I'm going to put down. Just kind of curious as to what type of, and if there's other things, again, that wasn't on the list, don't hesitate to throw them up as a question. Do you guys have a blower door, duct tester? How many people use an IR camera? Any kind of flow hood, either passive or powered flow hood? There's a variety of anemometers. There's a variety of ways to read pressure. There's a variety of ways to do your temperatures. A few more seconds. Still a strong group of blower door folks here. Surprisingly, very few actually have duct testers. That actually kind of takes me back. More people have an IR camera than they do have a duct tester. Oh, yeah, somebody mentioned that you have more than one of these pieces of equipment. When we set the poll, we have the option of just doing pick one or multiple. So we probably picked that so you can only do one. I apologize. So, and the results are, so I guess when I say 64% have a blower door, I bet many of you also have a duct tester, and that would make sense. That's kind of how many people that do these types of audits live, and so I bet that the number's higher on the duct tester because you chose blower door. I brought up an HVAC slide just kind of talk about some of the concerns that happen. Some of these structures are just like residential structures. You're used to seeing these types of registers and openings, and some of them are, again, a whole different type of condition, whether it's a split system, whether it's a package unit on the roof. And this is actually the simplified version, which is more of a residential application, but a lot of these strip malls, each individual unit has its own little HVAC system that's no different really from probably what you have in your own house. The question is, where are they getting their return from, or how is that actually affecting their envelope? One of the ones that actually is some people are familiar with or may not be is that commercial structures require a certain amount of, again, makeup air or fresh air or air for us to breathe while we're in these structures, and there's a variety of ways they can actually come into the structure. A common one is the economizer, which actually is trying to use the cooler air that might be outside to equalize the temperature that they want to provide. So when it's depends on the temperature outside, the actual fresh air may be a lot less, and then when the temperature is cooler, they need that kind of cooling effect, and a whole lot much larger amount of fresh air comes in. So these actually are in the code. They're described there. So one of the things I wanted to mention is that many people here are doing audits. There are a few HVAC contractors, maybe a few that actually are doing installation, but I think one of the movements that's happening in our industry is that it needs to be more of the KFC, Taco Bell at a gas station concept. That if you have not found a couple HVAC contractors that you really like to work with, or if you're an HVAC contractor, find a couple of energy auditors you like to work with, or the installation installers. More people that actually have those as a really good network that they can actually refer several people to, or really the people that are actually realizing how the industry is working in the future and how to make that happen, because not every company wants to have all of that kind of staff in-house, but that's actually the kind of business model that I see kind of playing out. The weatherization program is faded away, but there's a lot of knowledge and a lot of equipment out there, and people are trying to figure out how that happens. I did a presentation recently for a HVAC group, and their panic was they were afraid of another lack of a winter, no winter like they had last year. They said it was kind of crushing to their business that, if it turns slightly cold, everybody's happy, and then if it warms up, they're all kind of bumming because a lot of their service is based upon cold weather. So if you have not figured out a way to join forces, I highly recommend that's your future business model. All right, so I want to talk a little bit about testing and how many fans you might need. If you're doing standard or compliance, again, it actually is a kind of step-by-step. You do this, you do that. It tells you how to do it, how many fans you might need exactly. It gives you some guidance, maybe where they should be placed, but that's actually a common thing to resolve for these type of structures. It's usually only one or two access points anyway. Most of these structures can almost always be done with one or two fans, so it's not a large volume of air that you're doing for most of these structures. The thing we're trying to focus on is actually to improve the performance. So the type of test we're setting up is actually a very basic, where's my leakage? I actually can quantify the numbers and then repeat the test to confirm that it got better. So it really isn't a ASTM or an Army Corps type of a standard, even though I would be familiar with those kind of as a guidance as to which way you need to go. But in general, most of these structures could be done with just a manometer, and then add the test with your blower door. If you're doing a variety of standards, some of them say you must depressurize and then pressurize. I know those are some of the standards that are coming out even for residential, but our focus was that what are you doing to improve the performance, and you can depressurize a lot of these structures. And if you think about actually pressurizing a structure that may have challenges, and it's a restaurant or has any kind of food capacity or any other potential issues with all the dust and debris and challenges that happen with doing a pressurization test, that'll actually alter what standard you may be wanting to comply with or adjust your testing method. There is a document that we sent in the emails that actually goes through how many fans you might need, whether you're dealing with either square footage or surface area or volume. Most of the standards all deal with kind of surface area. I know that's much more common with codes now. Washington State and Seattle, they have a 0.4 CFM per square foot on the surface area. Army Corps and some of the other ones are around 0.25, and some of those numbers may be challenging to what we do residential, but commercial, once they've figured it out, they have got it conquered. So it's really they're much down to more like 0.05 is a common result for them. So it is achievable. There is a learning curve, and it can be done. So here's the visual what the document looked like that was in your email. If you deleted your email and you didn't realize it had a bunch of library of wealth of information in there, send us your email through the questions, and Sasha or Stephen will send you back a reply with the links for you. Here's the meat and potatoes I think a lot of people are wanting to find out about. So if we are going to do the basic test, and these are some of the conditions that happen, right, is what to kind of turn on, turn off, what to cover, what not to cover. So the general rule that is directly from Colin Ginge is that if it's on or operated all the time, right, we should not cover it. Those are openings that the structure almost always has and is always active with, right? And you're going to turn them off, but we're not going to cover them, and we'll test it with the system off. If it's something that's intermittent operation, like an exhaust fan in the bathroom that's not on all the time, or some other device that they may have for like welding or something like that, then we cover the opening and we test with it covered. And I have some illustrations of things that have to be covered, kind of reminding you of the challenges that go along with some of these. These are some hoods or an exhaust or something. These are more large building kind of concepts, but in general, these are things you've got to be aware of. You have access to, how long can they be shut down for. You know, some of these kind of tests can actually shut down the business, or you work Saturday and Sunday to actually accomplish these kinds of goals. Some people will kind of come late in the day, set up all through the night, test first thing in the morning, so they actually have a less of an impact upon their the occupants that actually are in the structure itself. Finding the leaks, as we both all know, isn't that challenging, right? So you can probably find it with your hand. The smoke puffer actually has become a challenge because of the mail. These are now like hazardous materials and are a challenge to actually email from either manufacturer. So they can feel expensive. There's a variety of options that are out there now. Retrotech has them, some of the non-hazardous kind of chemical that are out there. A lot of people that are doing these kind of larger structures will go with a handheld smoke or fogger, and you actually can pressurize the structure and go outside and see where the leaks are. And I've actually done this on several residential projects. It was good to see that many of you have an IR camera, and you know, you can actually determine the smoke, but the IR camera is a whole lot easier and less impact upon occupants. And I got this from Phil Emery out at he's actually in Washington State and does this regularly at Neudorf Engineers. He's also a NEB trainer. And this is a great slide that he uses, and it shows in the blue in the center there clearly where they forgot to put insulation in, sections that are missing. We definitely have a heat transfer that happens on the right side. You actually can see the studs plain as day. And we have a blower door happening right now, and on the left side you can see the feathering that happens, and that's actually caused by air infiltration, totally different from a thermal connection. And you kind of see it at the top too, where things are coming in up on through the studs and actually show up on the ceiling itself. So there's not a lot of time to be spent upon doing a large type of single unit itself. All right? It's pretty basic. These illustrations work for multifamily, and they also work for the type of structures we're talking about, which could be a strip mall or a structure maybe split or connected. A lot of doctor's offices maybe have on the right or left side. So again, you just have a single structure. We're going to pressurize, measure the CFM. So on this case, we actually have a leakage of 1,200 CFM. But the reality is I don't know where that's actually leaking to. And one of the things that I was reminded about by Stephen is that if you're going to do these types of tests, it is crucial that you at least know what's happening to the units that are adjacent to it. It's best that they can make sure that HVAC systems are off, obviously, but there should be some type of a window open or something cracked so that the pressure can actually be alleviated on the other side. Otherwise, you're not really getting accurate data. So as I test the center unit here, I want to make sure that the window or a door or something on each side is able to be opened so that the pressure that goes from the center unit has a place to go. Otherwise, if it's fairly tight on one side, I'm not actually able to get an accurate reading of the leakage from the center unit. So for multifamily, or it could be an enclosure that actually has a hallway like a dentist office or something, I can now still do the same test I'm doing, all right, still testing the same unit here in the middle. And now I've actually added a second fan, and I'm not reading off the fan, I'm just going to pressurize the hallway that's outside. Right? So what's going to happen now is that my leakage is going to drop, and I'm going to determine how much actually leaked from this unit into the hallway. Again, the two side units actually have pressure relief, so I can actually know that the area that is leaking from side to side happens, and I went from 1,200 CFM, and I'm now down to 1,100 CFM. So basically I'm actually just pressurizing here in the hallway, and I'm pressurizing the unit like I was, and now there's no more leakage that goes between the hallway and the unit. I understand there's some significant logistics to do this in multifamily, let alone commercial structures, but what may happen is that you end up finding that there's just more work in one complex that one person brought to your attention. So if you find that you have any kind of leaks in one part of the unit due to condensation, those types of problems, or comfort issues, and you go to the next unit to find out, hey, can I keep your doors and window open crack while I do this test? And you may find out they have the same issues. So you may end up actually dealing with an entire facility and not just actually an individual unit. So I did the same thing here. Actually, I can use another fan, but the reality is I'm actually trying to isolate the hallway and this unit by pressurizing them. Now the only leakage I have is actually going to the other unit. And again, it has a place to actually alleviate. So I went from 1100 down to 900. So now I know where my leakage is between this structure versus the hallway. And we'll do one more. I'm now going to open up the other section. So now I'm actually trying to pressurize all the sides around this unit, so I now understand the entire envelope. And it only went down 50. So I know that based upon this structure, that this adjoining wall right here, adjacent wall, is where the majority of my leakage is. And I can actually now kind of focus and do some more pressure diagnostics on this wall and determine what's going to happen. And I can retest to determine that I was successful in completing that. Retrotech is the software that allows you to run more than one fan together. It'll run one fan also. But if you have two fans and you want to actually combine those results, it's set up to run any kind of standard that's out there, from the Army Corps to the ASTM, or you can just set it up to run multiple fans at 50 pascals for whatever time you want and get the data. You can also use that data to determine infiltration and a variety of other effects that are common in these types of software. If you want to learn more about it, it's on retrotech.com, and you can also enter the information manually. I'm going to throw one more poll for you. What I'm really after is, what Retrotech is after, is what is it that we can provide, or it helps a lot if we get direction from the audience as to how it is that we can actually make the training for large building programs be more effective for you. Right now we're revamping, revitalizing, and updating the large building training that Retrotech has, and our goal is to come out in January with something that's mostly online live webinars, a series of courses you can take online, and as we travel around to all the venues, to be able to provide some live assistance to some of these criteria. The reality is it's a lot like your first blower door duct tester you did, where your client was standing on top of you going, oh, this is really cool, this is exciting, and somehow you kind of managed to get through it. These are a little more complicated, and but the reality is they're really not as tough to overcome. And like most things in life, once you did one, you realize, oh, it's not that tough. We will go through how to outline the criteria, how to set those up, the most top 50 things to do at the structure and where they're at, top 50 mistakes that all of us have made, and how to use the software and the equipment thoroughly, so that way when you are out there, you do feel familiar with it, even though it's a type of structure you actually may never test before. Okay, so our results are large building, kind of almost equal to energy savings. To me, that's a great thing to see. I think the Air Barrier Association and NAB are kind of pushing the environment here as to how this is going to play out in the codes and commissioning and a variety of other stuff. So, yeah, even though you guys have large building and energy savings as your top picks. All I do right now is going to just show you how simple it is to kind of run a basic test. So I'm going to exit out of here real quick. At the bottom I have the fantastic software. A lot of these things, like any other program you've had or things you've done online, you feel like, oh, there's a lot of stuff here, right? And what I really want to kind of go through is actually what is here and how we've actually kind of organized it. They have little sections that are actually able to be closed off so you don't feel overwhelmed by all the criteria that's here. So the top one is just telling me what test am I doing or what criteria could I do automatically. I can select a picture for the structure, all pretty basic. And then I can say, you know what, I don't need anything else here. I'm going to close that section. The next one is actually what equipment do I have, and one of the great features about this is I can just hit find gauges. Just say, are you sure? Because I've already got some set up. I say yes, go find what you got. And it'll go searching either wirelessly or Ethernet or a USB connection and find whatever gauges are actually connected to this computer and plot them here. I can determine which is the main gauge that's actually reading and controlling the fans, right? And the other ones are actually the subs that are actually just increasing and providing the pressure that I need. So I can actually adjust that up or down here. I'm going to do the new DM32 as the main gauge. It gives me the serial numbers, so I know which gauge that I may have if I have several of the same type. And I do have a DM2, which is the older unit. Many of you may have that, or the new DM32. All right, so I can also add one by just selecting it and doing it manually and putting that in there. It has some basic stuff that we're used to entering on a lot of our criteria and things we do at the structure already. Elevation, I'm in Georgia actually, so Atlanta is around 1050. I did a small structure that's around maybe 15 feet tall. It's a, we'll just describe it as a garage or a small unit by itself. I got 36,000 cubic feet. It's 3,600 square feet, and enclosure area is around 24,000. So I did about 10-foot high structure to make it work. It'll actually allow me to set the time and do a variety of other stuff, nothing big deal. I also can establish the temperature inside and out. I kind of give it a large temperature range. A lot of the standards and ResNet HERS requires that. I can either do an auto test or an ASTM, or I can just begin my own semi-automatic test. It's going to search for the gauge. It wants to know how I have them set up. Let's determine that. I can either do a fan speed, which is a percentage of the fan to run, or as most of us would do, we do a target pressure. To make it so it's not so loud, I'm going to enter 20. I'll do 25. That's a familiar number. I can enter any number I want, all right? And I'll tell the fans to update. And now they're actually seeking a target pressure of 25. Over here on the side, it actually has a digital readout of the primary gauge showing me the pressure that it's achieving. Sorry, I lost my small window. All right, now that they're running, I can actually do a collect the data. And it's telling me that I have set it up to do a data point for 10 seconds. I can actually make this actually the primary test. I can do a baseline or a final baseline. So I actually have the ability to actually do any kind of test I want and have that data show back up in the final results. Sorry, I'm trying to control my windows. Okay, I'll say stop and cancel. And it just took that criteria. You can see my pressure that I have right there, and was actually able to put it into the next opening. So I had a couple of tests I did earlier, only around 10 pascals, so it wasn't so loud, and able to get the criteria. It tells me how accurate the two fans were together. And if I scroll down, I can actually see the CFM, and I can actually calculate the infiltration or other criteria that usually is required. We could spend a whole good hour on the software. My objective was to show you that it's easy to input the data, it's easy to find, it automatically finds your gauges. I can actually kind of hit start, adjust some criteria, or just tell it to do an automated ASTM test, and it goes. Whether it's 5 points, 10 points, however many baselines I need, it's already actually pre-programmed. If you're looking for something that's really light and simple as a piece of software, then I have it for you. And you can download it. It works with the DM2 or the DM32. So if you have the older unit, older style unit, you can download this. Some people may have it already. If you're doing ResNet or HERS and you're a QA, or you're doing QA and PPI or any kind of QA, I guess, this piece of software is amazing what it'll do. I open it up and I'm connected to, here I actually connected 2 gauges. I actually have both the DM32 and the DM2 connected, and I selected I wanted to log them. I determined what intervals. It could be 1 second, 5 second, and then I hit start, and it actually starts logging the pressures on channel A and channel B and whatever results I actually have set up in the gauge itself. And I can let that go as long as I want. So for everybody who wants to actually make sure that your employee or somebody else, your QA, your provider, that they actually did what they said they were going to do in the field, this is the unit that does that, and it's free. So it's simple to use. So it's connected to the gauge, they hit start logging, and you can actually have this set up so when it saves, it could save it to a Dropbox. So it automatically is uploaded to you, and you can see it immediately. And the results are an Excel spreadsheet, which I didn't think you could read that very well, but I thought I would bring up a bigger one. So it tells me the gauge. You can see I have both gauges running simultaneous, and their serial number and how they were set up, what range they were, and the speed that was running. Only one of them actually is controlling my fans, and the pressures and the results and the timestamp. So, and this is a long page that goes through that. I can adjust the columns and actually make any kind of chart out of it, or plot the points. So for something that is free and simple to use, I found this to be a great product. I mentioned this in the beginning, and this is the kind of product that's going to change how people do testing, especially with all of the requirements with testing fans and determining from either code or compliance on how much CFM your fans are doing. So, I'm not going to go to the new ASHRAE standard or for or against in any way, but the reality is that we've been installing exhaust fans and kitchen fans that we had no idea whether they were even working, let alone how many CFM they were actually maneuvering out. And we actually have been checking CFM supply and return with passive flow hoods. This is a powered flow hood. It actually has a fan in it that can actually create the resistance and give you phenomenally accurate readings in just a few seconds. It's easy to use. It's incredibly lightweight. So if you're really looking for something that can test a kitchen exhaust fan, do the ERVs or HRVs, and obviously the exhaust fans you might have in the bathrooms, please contact us and we can let you know how the flow finder works. You did have some documentation that was included with your email you had. I had one last poll to end you with. Just kind of curious as to what your how many more NAB or PPI or ResNet or other. And again, if it's another, please send us a question response so we can actually evaluate that. I have a lot of other. I'm not sure. I don't have my certificate for other, but let me know what the other is so I can evaluate that. And here's the results. I got a couple NEB guys. If you're not familiar with NEB, I highly encourage you to take a look at what they do and how they do it. One of the things that's impressive about NEB is that if you're a NEB contractor and you bid a job and something doesn't go right, that NEB, the organization, will make sure it's fixed. And that's an amazing achievement for an organization of that size. So NEB as a group will guarantee that every install is satisfactory and kind of does a nice checks and balance on all their members. So it actually has a lot of credibility. So these are the upcoming webinars. If you do own a DM32 or you're interested in buying a DM32, next Thursday, same time, same place, we're going to go through that. Teach people how to update the gauge, whether you're home or not, you might want to just tune in to see how simple these gauges are. They really are going to change the industry and how they work. On the 14th, we have a really cool pressure and flow workshop. We're going to show you actually how to take a cardboard box and make your own little testing mechanism, and kind of go back to pressure flow 101 kind of workshop. So if you're a trainer, it's a great exercise. If you just want to kind of get a handle on ways you actually can improve your methods of testing and doing pressure diagnostics, that's right up your alley. On the 21st, we will be focused on multifamily. Similar to what we did here, but we're actually focused on multifamily specifically, kind of how to isolate a single unit and the challenges that come with multifamily. Heads up, if you do not have a flyer that's multilingual that you can actually slide underneath the door, asking them for permission to open the door, you may struggle. Here's one that's ahead of the curve. Is on December 12th, we will come out with our air leakage in large buildings webinar. That will be an overview of the training, and right now we have almost 250, almost 300 that registered, and we can only seat 500. So if you really want to get in the curve on the December 12th, send us an email. We'll make sure you're on the list, and we'll probably have registration for that in about 2 weeks or so, because I have a feeling that'll be a packed crowd.